Okay, question 1A. So, just looking at this road sign and thinking about where is the energy coming from for each bit. So the solar cell transfers light energy to, okay, so it's transferring the light energy up here and it's going to go into electrical energy first. And this is going to be stored in the battery. And the battery transfers, so thinking where is the energy in the battery now? So in the battery it's going to be chemical energy to electrical energy, again going back out towards the lights. And the LED transfers energy through a radiation or light pathway as it goes back out. Right, this next bit, a lot of you have put the right equation, so it's efficiency equals useful energy divided by total energy. But you've not thought really about which one's useful and which one's your total. That's what we've got to think about before we start doing anything. Right, the total energy input of the solar cells was 200 joules. So it's the total energy input is 200 joules. So we know the total is 200. And the useful energy output is 50. So it tells you in the question what these are. I think a lot of you have just looked at it and gone, well, it's 200 divided by 50, which gives you 4, okay? Because that looks like the most sensible way to do that, just in terms of numbers, but it's not the right answer. So we can do useful energy, which is 50, divided by the total, which is 200. Do that on calculator. 0.25. Now efficiency should always be less than 1. So if we've got an answer to more than 1, we know we've actually done something wrong there. Okay, on to question 2AI. So this is about describing how different power stations work. We need to have an understanding of what is actually going on. So with geothermal power stations, we get hot rocks underground, and we pump cold water down to them, which is then heated into steam by the hot rocks. So it returns to the surface of steam. The steam is used to turn a turbine, and this is the bit most people have missed, which drives a generator. Now whatever happens, it's always going to be something turns a turbine which drives a generator. The generator then produces the electricity. Okay, so if you have a look at a similar question, in question 3b, this is more linking this again into energy stores. So the water at the higher level in the reservoir, so up here, it's got gravitational potential energy. As it falls down, it's going to get kinetic energy, and the turbines and generators are going to produce electrical energy, as it says here actually. So at the top, what we've just said, it's going to have gravitational potential. I'm just going to put GPE because I can fit it in and you can actually see it. The water flowing then it's going to be kinetic energy, and it's going to wasted energy at the end is going to be thermal, as it often is. Okay, question 5a. So this is just looking at comparing energy resources from a pie chart. So just can we work out on pie charts basically. So it asks us which two energy sources do not produce any polluting gases. This is about understanding which one of these are burn and give off carbon dioxide and which ones do not. So the two that don't are going to be wind and solar. Okay, and then all we need to do is add the percentages up for those two. So it's going to be 12 add 25. It's going to give us an answer of 37% altogether. Okay, so starting with part B, I'm going to look at how we look at these longer questions, and it's asking us here to compare. So that's our command word today, to compare. So we're looking at advantages and disadvantages of the two methods of generating electricity. Now, a lot of us have done really well on this because we've first off picked out the numbers that we've got in here. So the wind turbine costs this much to install, and the generator costs this much to install, and the average power output of the wind turbine is 10 kilowatts, and the hydroelectric generator will have a constant power output of 8 kilowatts. So we've done really well with this bit as well as the information from figure 2. We've all compared that quite well. What most of you haven't done is this: use your knowledge. Okay, so you've got 6 marks in this, and just comparing these things at the top isn't going to get you 6 marks. So you've got to think, like, big term, how are you going to actually be able to get enough points in there to mention this? So I'm just going to show you how you plan this out rather than actually answering the full thing. Okay, so I'm going to start off thinking about, right, what are we comparing? Okay, so we're comparing wind turbines and hydroelectric generators. So I'll put that down here. Okay, and we're going to have to think of like a positive and a negative for each thing. So when we're writing this out, we say an advantage of this is this, however a disadvantage is this. So I'm going to put the positives first for each one. Right, remember with this, if you're comparing one to the other, you can't say the same positive thing twice, or you can't say, like, I can't say wind is cheaper, sorry, wind is more expensive as a negative, but then say it's a positive, that hydroelectric is cheaper. You can't compare one thing to another as just the opposites and expect to get the same mark for repeating yourself, basically. So I'll start off, right, so wind, one from the question, it produces more power. Okay, because it's 10 kilowatts, and in the answer, again, this is another thing people are struggling with, you'd then say in the answer, because it produces 10 kilowatts, whereas hydroelectric only produces 8 kilowatts, so you're justifying your answer. Okay, right, let's have a negative for that. Again, from the answer, it's average power, so it's not consistent. So that's kind of using this as well as your own knowledge. Okay, so it's not consistent power, it's not always working. Right. Before we start moving on to our own knowledge again, I'll think I'll go through hydroelectric now. We'll see what we can get from this. So, for hydroelectric, positive, it's cheaper. Okay, so it costs less to install. Now, again, this is kind of a little problem. You've got to say it costs less to install, and then justify again by saying by this much, because it's not cheaper overall, because once you've built them, they're both free, but it costs less to install in the first place. Right, then, a negative from here, again, you can't really say because it produces less power, because we've got that there. So I would say something like, it's difficult to find places to install, okay, or probably I'll put that one. Okay, or you could even say land must be flooded. For this to work. So we're getting answers from what we know as well. So think about for wind as well, what could we put? So if I put a negative, it can cause visual pollution. Okay. So that is to do with things like you can actually see the wind turbines. You could even put noise pollution. You could put it can cause damage to wildlife because it can cause damage to birds, things like this. So if you look now, we've got 6 points, and we've had to get a couple of points at least, and I'd argue that maybe they're not consistent, is partly from your own knowledge as well, from our own knowledge. We cannot get just enough answers by just saying this. So, you'd start off with An advantage of wind turbines is they produce more power because you can, as you can see, 10 kilowatts compared to 8 kilowatts. However, they are not consistent, and then explain that because it's not always windy. Okay, and then you might go furthermore, they cause visual pollution because they are easily seen. Okay, and they can cause damage to wildlife because they can cause damage to birds. And then you go on to do the same sort of thing for hydroelectric. So you need to plan this out first and think about, especially if it says it, use your knowledge. Okay, you can't just get away with just using the information from the question.